Consider this function from our list of famous Taylor series from page 3 of your packet. 1 over 1 minus x has a Taylor series centered at 0 of 1 plus x squared plus x cubed, etc. Okay. So I'm going to start by taking the derivative of 1 over 1 minus x using Calc 1 techniques. Nothing about series here. So I want to take d dx of 1 over 1 minus x, which I could rewrite as 1 minus x to the negative 1. And then I would take the derivative by doing the power rule. This is some stuff to the negative 1. So this is negative 1 times the stuff, reduce the exponent by 1, and then multiply by the derivative of the stuff, which is negative 1. So to simplify this, I get 1 over 1 minus x squared, which for the purposes of coming back to this later, I'm just going to point out that this is the same thing as 1 over 1 minus x times 1 over 1 minus x. Okay, so now I'm going to take the derivative of 1 over 1 minus x using calculus 2 techniques, meaning I'm going to take the derivative of the right-hand side of this equation, take the derivative of the series. And it says write at least 4 terms. So the derivative of 1 is 0, then 1, 2x, 3x squared, 4x cubed, etc. Okay, so I wrote 4 terms that are non-zero, 1, 2, 3, 4. That's good. Now, I want to confirm that these two ways of calculating the derivative give you the same answer, right? So I have d dx of 1 minus x to the negative 1 is the product of 1 over 1 minus x times 1 over 1 minus x. And I want to show that the series for that is the same as this series. So 1 over 1 minus x times 1 over 1 minus x, I'm writing out the series of 1 over 1 minus x twice. I'm going to multiply them together. So this is just distributing a lot of stuff, distributing everything to everything else. So I'm going to start with the 1, and I'm going to distribute this 1 to every term in the other parentheses. So I get 1 plus x squared plus x cubed plus x to the 4th plus x to the 5th plus ... Then I'm going to distribute my x to every term in the next parentheses. So x times 1 is x, then x times x squared, x times x is x squared, x times x squared is x cubed, plus x to the 4th, plus x to the 5th, plus x to the 6th, plus ... Okay, then I'm going to distribute my x squared to every term in the next parentheses. So x squared times 1 is x squared times x is x cubed. Okay, and then I'm going to distribute my x cubed. X cubed times 1 is x cubed. X cubed times x is x to the 4th. And okay, so let's see. These are, I'm adding up infinitely many infinite sums here, but let's see if I just start adding these up, what happens. So I have a 1. I have x plus x is 2x. X squared plus x squared plus x squared is 3x squared. X cubed plus x cubed plus x cubed plus x cubed, that's 4x cubes. And then I have 4x cubes. Then I'm going to have 5x to the 4ths. If I had distributed one more time, I would have 5x to the 4ths plus ... That is the exact same series I got here. 1 plus 2x plus 3x squared plus 4x cubed. Same thing. Okay, in your reading this year, you encountered something called the sine integral, shorthand psi of x. It's the integral from 0 to x of sine of t over t dt. So some engineers and scientists use this function a lot, particularly in optics. We want to find a Taylor series expansion for psi of x. So we start by replacing sine t with its Taylor series expansion. And the Taylor series expansion for sine x is x minus x cubed over 3 factorial, blah, blah, blah. Okay, so psi of x is equal to the integral from 0 to x. Instead of sine of t, I'm going to put its expansion, which is going to be t minus t cubed over 3 factorial plus t to the 5th over 5 factorial minus t to the 7th over 7 factorial plus dot, 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 all over t dt. I'm going to divide t into each term of the numerator. So t over t is 1. T cubed over t is t squared. T to the 5th over t is t to the 4th. And then t to the 6th over 7 factorial plus dot, 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 dt. Integrate term by term. So the antiderivative of 1 is t. The antiderivative of t squared is t cubed over 3. And then t to the 5th over 5. T to the 7th over 7. And I'm going to evaluate this from 0 to x. So when I plug in an x for all my t's, I get the exact same thing here. It's just I have x's instead of t's. So this is x minus x cubed over and then when I plug in 0 for all the t's, I'm going to get 0, so I don't need to bother doing that. All right, find the Taylor series expansion for each of the following functions about a equals 0. Write out at least 5 terms. F of x equals 1 over 1 plus x. So we're supposed to find this by substituting into the Taylor series expansion for 1 over 1 minus x. So if you don't know off the top of your head the Taylor series expansion of 1 over 1 minus x, you can just look it up in the second page of your packet. So 1 over 1 minus x, its expansion is 1 plus x squared plus x cubed plus x to the 4th plus dot, dot, dot. So 1 over 1 plus x, that is 1 over 1 minus negative x. So you'll see I'm just replacing this x with a negative x. So that means I'm going to look at my series for 1 over 1 minus x and replace every x with a negative x. So I have 1 plus negative x squared plus negative x cubed plus negative x to the 4th plus dot, dot, dot. And that comes out to 1 minus x plus x squared minus x cubed plus x to the 4th minus dot, dot, dot. Okay, now I'm going to do this another way. Another way of getting the exact same series is to take the to differentiate ln of 1 plus x. So I'm going to start with the ln of 1 plus x series, which you could just look up in your packet. It is x minus x squared over 2 plus x cubed over 3 minus x to the 4th over 4. Okay, so take the derivative of both sides. The derivative of the ln of 1 plus x is 1 over 1 plus x. That's the series I'm looking for. So I'm going to take the derivative of the right-hand side, and I get 1 minus 2x over 2, which is x, plus 3x squared over 3, which is x squared, minus 4x cubed over 4, which is x cubed, plus 5x to the fourth over 5, which is x to the fourth. And you get the same thing that we got above. Okay, now I want to come up with a series expansion for 1 over 1 plus x squared by substituting into 1 over 1 minus x. So 1 over 1 minus x, its expansion is 1 plus x squared plus x cubed plus dot, dot, dot. So what do I have to replace x with to get 1 over 1 plus x squared? I would say I will plug in, instead of x, I'm going to do 1 minus negative x squared. That would simplify to 1 plus x squared. Okay, so in my series expansion, I'm going to replace every x with a negative x squared. All right, and now I'm going to simplify a little bit. This becomes negative x squared. And then negative x squared squared becomes positive x to the fourth. Negative x squared cubed, that's negative x squared times negative x squared times negative x squared, which is negative x to the sixth. And then negative x squared to the fourth, that's an even exponent, so it becomes positive x to the eighth minus dot, dot, dot. All right, I want to come up with a Taylor series for arctan by integrating the Taylor series from C. So I have my Taylor series for 1 over 1 plus x squared. That's what I just came up with. It's 1 minus x squared plus x to the fourth minus x to the sixth plus x to the eighth minus, and I'm just going to integrate both sides here. The antiderivative of 1 over 1 plus x squared is the inverse tangent. And then I'm going to integrate term by term on the right. So the antiderivative of 1 is x. Then I have x cubed over 3 plus x to the fifth over 5 minus x to the seventh over 7 plus x to the ninth over 9 minus dot, dot, dot. Okay, so now I want a series for x squared times the arctan of x, which means I should just multiply my series for arctan by x squared. So x squared inverse tan x is equal to x squared times the series I just found for arctan, x minus x cubed over 3 plus x to the fifth over 5 minus x to the seventh over 7 plus dot, dot, dot. Distribute my x squared and I get x cubed minus x to the fifth over 3 plus x to the seventh over 5 minus x to the ninth over 7 plus dot, dot, dot. Okay, I want a series for 1 minus cosine x over x squared. I know a series for cosine x, so I'm just going to plug it in here. So I'm going to do 1 minus, the series for cosine x is 1 minus x squared over 2 factorial plus x to the fourth over 4 factorial minus x to the sixth over 6 factorial plus dot, 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 all over x squared. I'm going to distribute the negative and combine any like terms. So I have 1 minus 1 is 0. Then I'm distributing that negative. So I have negative times negative x squared over 2 factorial, which is x squared over 2 factorial, minus x to the fourth over 4 factorial, plus x to the sixth over 6 factorial, minus dot, dot, dot. Divide that all by x squared. And then you can put that x squared under each term of the numerator. Divide that x squared into every term. So I get 1 over 2 factorial minus x squared over 4 factorial plus x to the 4th over 6 factorial. Maybe I'll write out one more term here. If I follow the pattern, I get x to the 6th over 8 factorial plus dot, dot, dot. Okay, the last thing I want here is to take the antiderivative, sorry, the integral from 0 to x of 1 minus cosine t over t squared dt. So this, I just got a series for. I'm just going to use t's instead of x's here. So this is the integral from 0 to x of 1 over 2 factorial minus t squared over 4 factorial plus t to the 4th over 6 factorial dt, and integrate term by term. So I have 1 over 2 factorial times t minus t cubed over 3 times 4 factorial plus t to the 5th over 5 times 6 factorial minus t to the 7th over 7 times 8 factorial, evaluated from 0 to x. So I'm going to plug in an x first, and I get 1 over 2 factorial times x minus x cubed over 3 times 4 factorial plus x to the 5th over 5 times 6 factorial minus x to the 7th over 7 times 8 factorial plus dot, dot, dot. And then when I plug in 0, I get 0, so I don't have to bother doing minus 0. This is just the answer.